Ok. Entonces y-z es -3, -1, -2, -3. I plot that point. Okay, que es de y-z. And from this point, using a slope, in our case, slope is equal to 3/2. Remember, slope is by definition is the ratio between wrong and rise in the top, wrong in the bottom. Es obvio que rise is 3 and wrong is 2. Therefore, from this point, I'm moving over 3 units, 1, 2, 3. We are in the origin, and 2 to the right, 1, 2. And we get the second point. By the way, this point is the point 2, 0, no? And this point was 0, -3. Now this is a moment in which you're connecting this by the line. The problem is what kind of line? We come back to the original problem. No, original problem is inequality. This inequality is a strict inequality. A strict means que do not include equal sign. No equal sign is a strict inequality. And the representation is using a line, pero dotted line. So any problem can have less than or greater than, you use a dotted line. Any problem can contain less than or equal or greater than or equal, you put a solid line. This is a convention. This is a convention that we are using because what is the idea behind this? The idea is, I suppose, that this line represents the boundary between two semiplanes, the above or below semiplane, and when there's no equal, that means that the boundary do not belong to the solution. Now, to find what part belongs to the solution, well, there are many ways, guys. I want to explain both ways. Suppose that you, for example, again, you copy the original inequality. And solve for y again. -2y less than -3x plus 6 divided by -2. I want to do again this process. Entonces y is greater than, this is important because in this moment I divide it by a negative number. I know that when this situation happens, the inequality is reversing the sign. It's not less than anymore, now it's greater than. Greater than what? Greater than 3/2 positive x minus 3, no? Now you convert to equation, no? We come back at the beginning, no? Okay. The equation helped me to do the partition of the whole plane into semi-plane, but looking this symbol, is greater than, I suppose it's above the line. Yes, this symbol is below the line. Now you highlight, the solution is this region. This completely semi-plane, no? All of them points satisfy this condition. The point exactly on the line, no. And another point here, no solution. This is one way to do. Another way to do is using testing point. You select testing point, arbitrary testing point. The most common testing point is 0, 0 because 0 is easier. 0, 0 is a point here, 0, 0. Yeah, I'm plugging it into the original equations. Remember, we have two possibilities. It's above or below. We say 50-50. Therefore, it's super easy to discover what semi-plane is this. Using testing point, you plug in the testing point into the original equation. It's 3 times 0 minus 2 times 0 should be less than 6. And 3 times 0 is 0, and 2 times 0 is 0, and 0 minus 0 is 0, and 0 is less than 6. This system is completely true. Therefore, I realize that 0, 0 is inside the solution region. Therefore, See, you select another point here, maybe it's completely false. This is one possibility. One possibility is, personally, I don't know why, but I like that way. So the way que you solve for y, entonces ahí, using my common sense, si es greater than, es above the line, si es less than, es below. Make sense, no? Or testing point. Either way. Any question, guys? This is doing by hand. Of course, after we have two more examples, and we go over to the system, because system means different inequality together. And this is very, very confusing doing by hand, and we are doing using Desmos, no? Because it's easy to see. Any question? No question? Everything is clear or confusing? This look like intermediate algebra. Okay. Clear. Yasmin. Okay, let's discussing two more examples by hand. Example 2 is x squared plus y squared less than or equal 4. This is non-linear. Non-linear. Linear. Non-linear. Inequality. Okay. Entonces I focus in the equation part. I realize, wow, it's a circle. It's a circle with the center is located at the point. Center is located at the point 0,0, no? And the radius is square root 4, que es the right hand side number, que es 2. Okay, entonces it's a circle. It's a circle. So do you want to represent the points? It's a circle, radius 2, 1, 2, 1, 2, 1, 2, 1, 2. It's a circle. What kind of circle? Solid or dotted? Solid. This is always the dilemma. Or dotted line. It's solid. Why? Because it's equal. So I suppose that the boundary is my circle included inside the solution because it's equal. Si es no equal, entonces es dotted circle. Ahora, the problem is inside or outside? In or out? Es obvio que es inside. And one fantastic way to verification is using the testing point, que es the origin 0,0. So you plug it in the origin as 0 squared plus 0 is less than 4, 0 less than or equal 4. This statement again is true. This is confusing. Some students ask me, well, this statement is true, this is true. But this is not true. And remember, this symbol is a combination less than or equal to. Equal to. And this conjunction or in mathematical logic, so you satisfy at least one condition, the entire statement is true. So basically, in my mind, this is or, no? And this is true. It's obvious it's true, no? And this is false. But the compound statement formed by the conjunction, in this case, it's not conjunction, it's disjunction, it's the technical name in mathematical logic. See, one statement is true, the entire statement is true. To and see, I connecting by and no, I'm speaking, and to be true both in order to be true the compound statement. But don't worry for this. Okay, this is completely true, less than or equal 4. Therefore, the part solution is the part inside the circle. Easy, eh? Complementary to the example 2, I have example 3. Okay, example 3 is exactly the same, but I changed something now. I change greater than 4. Wow, it's the same, no? It's the same. No, it's not the same. It's different, right? It's exactly the opposite. The complementary part is I suppose que it's totally outside the circle and include the boundary que separate both regions. Of course, no. It's the same. Two. Okay, it's a circle. Again, using green color. It's a circle. Radio 2. But in this case, this circle is no solid. It's dotted. Actually, it's dotted circle. And it's obvious that the complementary part is completely out of the circle. Let me use the highlight in this region. All the plane except the point inside the circle. That's the solution. Okay. Any question, guys? Super easy, eh? Super easy. Okay. Now, the system is not easy. Because the complication can introduce in the system is that it's too many regions and you need to identification. Yes, it's pretty simple, yeah. Okay, Sean, but the problem is when there's a system. System is, let me start for elementary example, no? No big deal, no super complicated. Okay, now example number 1 of the system. In the system we have several inequality, no? Suppose 3x minus 6y less than or equal to 12. This is the first inequality, and the second is 2x minus y greater than 4, and this is the inequality number 2. So you can do the graph of this inequality separately. You do the graph of the second, and together, que se compound idea connecting by and. And remember, and is intersection. Because, okay, here I don't see any and. However, default, everyone understands. Okay, you need to satisfy this equation, this inequality, sorry, and this inequality. Entonces, default is always and. Bueno, sometimes specification que no and, pero the most common, si no specification, default, you suppose que es and. Okay, but let's solving. My recommendation is in the test, you're using always Desmos for solving system. No? Okay, entonces let's move on to Desmos que I have here. Okay. Okay, there you go. This is Desmos. Do you see Desmos? Okay, super. Now let's do it in the first one. This example we are doing is number 1. Okay, number 1, remember, is 3x minus 6y less than or equal to 12. I just copy like that. Exactly. No transformation, no isolated, no. I have here a common point. Okay, a common point is the intersection. Look, let me show you. Okay, look. Suppose that you are doing the graph of the first inequality only. You say this region. And when you are doing the graph of the second, entonces my recommendation is using the same color. Because you see, it's a black, but actually it's not black, it's gray. Now, if you plot the second, entonces what is the solution? The solution is the darkness, que es the intersection both. And that's it. And that's it. We can do by hand. We can. It's easy. It's no big deal. However, I highly recommend doing by this. Okay, and what about this point? How you get the point? Easy. You suppose equal sign both, and you intersect in the system, and this is the solution for the system. But it's not strictly mandatory. It's 4 over 3, comma 4, negative 4 over 3. It's this point is the common point. Any question? Any question? Any question? Entonces I bring, I bring several examples, more complicated. Suppose, let me switch into the whiteboard. Guy, let me know if you understand or you don't understand. It's easy, it's clear. I suppose that you are strong. Clear. You are strong using decimals, no? You have no problem with using decimals. Let's do in curiosity. Several examples. Example 2. Example 2 is 3x plus y less than or equal 6. Inequality number 1. The second inequality is 2x minus y less than or equal negative 1. So far it's linear inequality. And x greater than negative 2 is the number 3 inequality. And y less than 4, number 4 inequality. This system contains 4 inequalities. You need to find the intersections. Each inequality represents in the two-dimensional plane one region. So what is the solution? The solution is the intersection. It's the common part that these inequalities share. So this looks like complicated. However, in decimals is no big deal. Let me try. Okay. Example 2. Well, example 2 consists in, do you see decimal, right? Yeah, I forgot something, no? Okay, Sean, thank you. Okay, you copy the 1 by 1, the inequality. Okay, is 3x plus y less than or equal 6. The second is 2x minus y. If you want, we are doing 1 by 1. Okay, and the third one is x greater than negative 2, and the last one is y less than 4. And when you are doing everything wrong, wait, you can see, look, let's do it 1 by 1. Suppose this, no, and no. Okay, the first inequality, the solution is this. Is below the line. Make it sense because it's simple, no? The second is, in this case, is above. It's less than, but you have negative y, and when you isolate the y, you divide by negative 1. This is obvious that it's changed this sign. The third one is greater than negative 2, so it's to the right. Because it's the vertical line. The vertical line is not above, below. It's right or left. So it's to the right because it's greater than. And y less than 4, the related line is a horizontal, but it's below, so it's down. Bam. Therefore, the solution is the darkness, the dark regions is the intersection. It's important to understand that sometimes, not always, the solution represents the polygon. In this case, 1, 2, 3, 4 quadrilateral figure. Okay, and it's important You see why it's important. Determine the vertex. The vertex, in this case, the vertex, I compute the vertex. Okay, the vertex is the intersection. So you select, you convert everything to equations, and you pair the equation to linear equation, and you find the solution, no? So now another couple, we find another solution, another couple, you find another solution, and finally one more solution. So we have 4 solutions because we have 4 vertex because of the quadrilateral figure. Okay? Super easy, super clear. Don't waste the time doing by hand because it's no super hard, but the answer should be, yeah, 4 point. No, Sean. The answer is not the 4 point. The answer is the region inside this. The answer, we can represent algebraically, but it's hard, very hard. If you want, I do for you, but no, it's super hard. The answer is graphic. So you suppose I put it in the test, some part of that, you put in decimals, and you take a picture, no? Well, you know how you share here, okay, and export as an image, okay. And this is the okay, this is the solution. The solution is this. Okay, I suppose that the point is very important to understand much better the region, you know. The vertex is important to understand, and also it's important for the next topic that we discuss, in case the application of this. Okay, let's do one more example. Let's move on to the whiteboard. Example 3. Okay, example 3. Sorry. Okay, example 3. Let's do example 3, example 4, and example 5, and that's it, because it's the same routine. Example 3. Example 3 is, suppose 2x plus y less than or equal 6. Inequality number 1. So far, the inequality that we are discussing are linear, but not always are linear. You see another example that is non-linear. Okay, suppose this x greater than or equal 1, less than or equal 2 is inequality number 3, and y less than 3, number 4. Okay, look, suppose we are solving this. This is a linear. Okay, this is another linear. This is exactly 2 vertical lines. So see, you are doing the graph of the number 3 is in between 1 and 2. A solid line, no? Yes, exactly the bunch of value here in between this, because it's in between 1 and 2. And 3, 3 is a horizontal, and 3, 1, 2, 3, right? And the region is below. The below is that part. Okay, that means this is y less than 3, okay, is below, and the intersection is obvious this part, not this part, this part. But no, don't complicate your life. Let's go in decimals, and we solve in decimals. Okay, decimals. Okay. Example 3. Look at that. Example 3 is a collection of the inequality. Okay. And we are doing together. Look, it's something like that. Wow. Okay, let's do it one by one. This is a line. This is below the line. This is another line. It's above. Because the greater than makes sense, right? This part is this. Look. And this part is this. And together, everything together, bam, bam, is this. Look. In this case, we have in our hand 1, 2, 3, 4, and 5. A pentagon. So the solution is the polygon that have 5 sides. And the vertex is 1,3, 1.5,3, 2,2, 2,0, and 1,1. Okay, this is the solution. And the vertex is important because give me a corner of this closed set figure. In this case, a pentagon. 1, 2, 3, 4, and 5. Yeah, 5 sides. This is easy, it's clear, understandable, no problema. Okay, let's, how do you write the answer? How do you write? I say amazing. Look, Vance, how you write the answer? The answer is not impossible, pero es useless. Write algebraically. Is basically the answer is graphically, like that. You export the figure. And this is my answer. Look at that. This is my answer. O sea, I understand very well que the dark part represents the solution, and the corner is the vertex bounded somehow. And you discard in the test. Make sense for you? Okay, super. Okay, let's discuss it now. 2 more examples of, but in this case, no linear. No linear. Wow. Okay, no linear now. Okay, there you go. And those decimal automatically do. Yeah. Well, no. In that way, you need to select the same color. O sea, the key idea, bueno, que I saw, no? Si you are using the same color, entonces, when the one region overlap, you see a little bit dark, okay? Suppose this example, okay, it's example 4. Let's do it together, example 4 and example 5. Okay, it's exactly the same idea, but in non-linear. Look, example 4 is x squared plus y squared less than or equal 16. This is the inequality number 1. And the second inequality is x plus y greater than 2. Okay, easy, it's only 2 inequality. The first one is obvious, it's a circle. Circle, center at the point 0,0 is the center. And the radius is 4. It's the square root 16. Y I suppose que I highlight inside the circle, inside. Because it's less than, no? And this is a line, this is a linear. Okay, you see, apply the same procedure, you solve for y, you know, but in decimal, you don't need to solve for y. Okay, let's see in decimal. No. Okay. Do you see decimal, right? Remember example 4. It's a circle. Okay, Sharon, thank you. It's a circle and underline. Let's see. Bang. Make a zoom to see much better. Okay, we have a circle. Look, the first one is a circle. It's the region inside because it's less than. And the line is, this line is above the line. And the intersection above is this region, que es the solution. The solution is this arc, arch, bounded by this arch and this segment line. So the darker part represents the solution. Okay, and you in the test, easy, you share with me, export as a PNG format. This is my figure. Okay, entonces I understand very well that part. It's easy for me. Okay. Now, let's do one more. This is a little bit complicated. Do you see the whiteboard now? Yeah, example 5. Example 5, Jasmine, is parenthesis x minus 1 square plus y plus 1 square less than 25. Suppose another case, x minus 1 square, well, it's the same, plus y plus 1 square greater than or equal to 16. Wow. Wow, what is that? It's nonlinear, right? Nonlinear. But this is circle. This is circle. This is circle with the center is located at the point 1 comma negative 1. Okay, this negative 1 representing the point positive 1, and this positive 1 representing the point negative 1. Don't worry for this, because in the last chapter we studied in detail the equation for the circle and any conic sections. Okay, but I anticipate something. And the radius is 5. Where I come from this 5? Square root 25. Square root 25 is 5. This is center. And I know it's less than, therefore it's inside. So basically, we have the famous point 1, comma, negative 1, comma, negative 1. This is the center, and we have a circle here. And this circle, the radius is 5. But I suppose something like that. The solution, at least the first, is just the inner part. Okay, and this is similar. This is the another circle with the same center, but the radius is 4. The radius is 4. Where I come from, the 4 is square root 16. That's 4. Okay, we have a circle here. This circle is, let me using another color. Same center, but the radius 4. It's supposed to be a smaller radius, but in this case, no dotted line is solid because it's greater than, so I included the boundary, right? Therefore, in my opinion, the common part share both region is inside the first circle and outside the second. That part. Okay, by the way, look like a ring, no? It's clear as always confused. Okay, just in case, to want to make sure in the decimals. Now decimals, okay, decimals. We're switching to decimals. Wow, to see more clear. Okay, we are talking about example 5. Example 5 look like that. Boom! Look at that. Okay. Let me try. Step by step. Okay, suppose the first inequality is a circle. The radius, the center is located at the famous point 1 comma negative 1 here, approximately. And the second is completely outside. Look, outside, and both together is the ring. Any question, guy? No? Wow. Good, very good. Okay. You feel good? Okay. Application of this now. Application of this now. Okay. Application of this now. Okay. One important topic in the optimizations is linear programming. Wow, this is a sophisticated name. Linear programming. This look like a computer, no? But actually it's not a computer. This is optimization problem. Optimization problem. Linear programming is optimization problem. And what is the idea for optimization problem? Well, optimization problem is very, very similar to the thing we're discussing so far. It's a system of inequality, but you have, okay, basically any optimization problem contains two pieces. The first one is the most important piece, is the objective function. And the objective function is the function that you need to optimize. You optimize means in mathematics, try to find the best option. Maybe it's a maximum or minimum, depending on the situation. No, the problem, suppose we are talking about the profit of business, because I want to optimize. You maximize the profit because it's good, no? However, so you are talking about the cost of the business, it's obvious you need to minimize. So this is the first expression is called objective function, and we have subject to the second piece of the optimization problem is the constraints. And the constraints is a series. Let me spell it here. Constraint. I forgot T here. Constraints. T. And normally the constraint is the set of the system of inequality. Que somehow give me information about the limitation, the physical limitation or the logical limitation of our problem. Okay, let me try to present to you the first example of the linear programming. The linear programming is suppose it's giving one set of the inequality. Okay, inequality number 1, inequality number 2, inequality number 3, inequality number 4. And this represents the constraints. Now we have objective function. Objective function normally is called z, I don't know why. It's 250x plus 150y. Okay, this is my objective function. So what is the problem? What is the goal? The goal is optimize this variable c, and they want can you find the maximum value. Pero no arbitrary maximum, sino the maximum que lie inside this figure. Therefore, the strategy for solving any problem of the linear programming is you start first by the constraints. And the constraint give me, for example, a polygon. I don't know. Suppose a polygon like that. Boom, boom, boom. Suppose a triangle. Suppose like that. And you determine the corner. Just everything inside the closed figure is the solution of this system. Now it's feasible. It's realistic, to satisfy this system of inequality. Outside, no, completely false. No satisfy the system. Now you need to evaluate the objective function C at any point inside the feasible region. But we have infinity point. No. The maximum or the minimum always occur in the corner of this. You evaluate the objective function here, C1. You evaluate the objective function here, C2. You evaluate the objective function here, C3. And you take the maximum value. Suppose que, I don't know, in C3 the answer is 0. In C1 the answer is 11,000. And C3 the answer is 9,000. And you take the maximum. Where's the maximum? This is the maximum. Okay, this is the maximum of this function. Okay, obey this, and also we can find x and y. You find x and y can satisfy this condition. Okay, let's solve in this, but of course, again, we have the same situation. Okay, we have system of inequality. To say we solving always using Desmos, no? Get the famous graphic calculator. Let me try. Do you see Desmos? Good. Okay, this was the previous example. Let me try to find now linear programming. Linear programming here, over there. Linear programming problems. Similar, you know. I copy the constraints, so the system of inequality. For example, let me try to interpret this idea. X greater than or equals 0 is, hello, wait. Okay, x greater than or equals 0, not too much. Okay, let me enable this and analyze one by one. Okay, greater than or equal to 0 is that part. So only x positive. Now, y only positive. Look at that. It's the first quadrant. It's obvious. And normally in the real life problem, you don't need or you have no sense to talking about negative. Suppose case we discussing one problem is about the items, the package. I don't know, you see after that one problem is about the tree. And to say have no sense to talk about negative tree, no? So negative package. Okay, so I plot one by one, I solve the inequality part, boom. There you go. And you find the corner. So I detecting, okay, we have forget about this for a moment. This blue part is not important. So we focus in the constraint, que is a system of inequality. I determine it's a triangle, and we have two vertices, que is 0,60, 20, 40, and 0,0. Okay. Now I go to the objective function. I put the objective function. Objective function is a line, and the string is a line, and the line you can take any value. Okay, here. Okay, and so you evaluate. Look. I create like a slider here. But it's easy. Okay, I copy the value. Okay, 0,60, x, y, 20, 40, and 0,0. Entonces, manually, you can see here que the maximum occur in 2040. Que by the way is 12,000 or 11, I don't know. Let me see. Let's come back to the, I discovered that for my problem, I have 3 corners. The corners are 0,60. The other corners are 20,40. And the last corner is 0,0, no? And you evaluate one by one in the objective function. So C is equal 250 times 0 plus 150 times 60. And the answer in this case is 9,000. And the C is 250 times 20 plus 150 times 40. I put in the calculator, of course, it's 11,000. Okay, and the last one is obvious 0, because 0, 0 is 0. Then the maximum value. So what is the answer for the linear programming problem? Okay, the objective function is maximized at the value 11,000, maybe it's dollar, I don't know. And this happened at the point 20,40. So x is 20 and y is 40. Get the idea? Get the idea or no? Confusing? Clear? Linear programming. Linear programming is one application of the system of inequality, right? But the system of inequality is the constraints of the problem, and we need a little confused. Okay, Sean, listen to me. Any problem of the optimization, in general, in mathematics, in advanced mathematics, and elementary mathematics, optimization means find the best option. Normally it's maximum or minimum, depending on the nature of the parameter we are discussing. And any optimization problem, always, anytime, in calculus 3 and calculus 20, we have 2 pieces of information. The first one is the constraint, it's the most important. The objective function, is the most important. Is the parameter, is the variable that I want to optimize. Optimize means maximum or minimum, right? Now, this is completely free? No, not completely free. It's subject to the different constraints of the problem. And the different constraint of the problem is a system of inequality. Now, you're solving the system first. When you're solving the system first, normally in linear programming problem, not always, but 99% of the case, we have a closed figure, a closed, not necessarily triangle, maybe any polygon. And you evaluate the objective function in the corner. Because in the corner, I suppose, look, why is the reason it's in the corner? Okay, and this point is good, satisfied. Suppose, but it's no maximum, no minimum. It's maximum or minimum. Suppose here, no satisfied. But this channel is the first guy is satisfied. So this point is important because this point maybe is a maximum or is a minimum. Not always is to the right or to the left. Some problem depends on the nature of the objective function. Is a line. Normally it's a linear programming. So this objective function always is linear. So it's linear. Suppose it's like that. So the optimal is this. Okay. 2 more blah blah blah. No. Not good. I present one word problems that we're solving by linear programming. And you see the completed picture of the application of this. Okay? I can see the screen. I'm going exit to the comeback. Okay. Sorry. It's a line. Okay, you see, you don't see, when I explain something, you don't see the whiteboard, no? Now you see the whiteboard? I see it. Okay. Okay. Don't worry, guys. Let's go directly to the. I prepare for you one PowerPoint presentation. If you want, when the class is over, I send. Don't waste the time to copy this. Because I send the PowerPoint with the video. Okay. I would take a picture that they send. Yeah. No, not exactly. In the linear programming, you need to find result, numerical result. Okay, suppose this problem. Let me read the problem. Let me try to understand the problem. And let me try to solve the problem. A plant nursery sells 2 sizes of oak trees to landscape. The monthly demand is at most. Well, you need to translate what means at most. At most is less than or equal to. Make sense, right? It's a little bit contradictory, the word with the idea. At most is less than or equal 310 oak trees. Furthermore, the nursery does not want to allocate more than $29,700 each month on inventory. That means the total money is less than, because allocate more than. It's a negation. Do not want. This is the problem of the word problem. Okay, sometimes in language, you negation and double negation. Okay, but in this case, no, they don't want to allocate more than. In other words, you translate this like the total money investing in these three is less than 29,700 each month on inventory for oak tree. Determine the number of large oak tree and the number of small oak tree. Oh, we have 2 categories. We have large and small that the nursery should have in each inventory to each maximize the profit. Oh, okay, I understand that the objective function is profit. Okay, the number que I want to optimize is the profit, que the profit is good, entonces I need maximize. It's obvious, right? And the cost is bad, guy. I need to minimize, you know. So the information is given about the tree is, we have a small tree and the cost is $70 and the profit is $29. Entonces you say, no, well, so something is wrong. You get less money than your cost. No, remember, revenue is a cost plus profit. Okay, entonces the money que you go back is the 70 plus 29. And 29 is totally profit. It's free money in the business, right? And the last three is 110 is the cost and the profit is 55. Okay. Entonces, this is the problem, the problem, the contradiction for the word problem. Okay, you never can see a word problem in my test. I only put here to illustrate the application. But however, you can see linear programming, pero theoretical. You don't know si es tree, si es dollar, si es money. Okay, the linear programming contains 2 pieces: the constraint and the objective function. No? And that's it, right? Okay, so now let's try. What is the objective function in our problem? What is the objective function in our problem? Well, the objective function in our problem is the profit. Okay, I want to call C. I don't know why. Normally, a linear programming problem called C, the objective function. This is profit. is equal 55 multiplication by the amount. Okay, I define one corner of the piece of paper here. Okay, X represents the large tree and Y represents the small. Okay, anyway, some people switching that, or some people call L and S, doesn't matter. It's not important, it's just a variable. A 55 multiplication by the large, the amount of large. So this represents the amount, number of large tree, physical, multiplication by X, plus 100, but wait, 29, sorry, is the profit, Y. Do you understand this equation or no? So the only thing I did was define X represent the large tree, the amount of number, the number of the large tree that you need to sell. Okay, I have no idea. This is my goal. And Y represent the amount of the number. Are you? Yes, I suppose. I suppose, Jasmine. No? Okay, let me check it. Check it. Okay. Now, Jasmine. Okay. Repetition again, the same idea. Okay. The first thing you should do is define the objective function. The objective function is the function that states the relationship between profit. And profit I want to call Z. I don't know why. So I take the column in the PowerPoint, que es the profit, no? Y I define here in that corner que X represent the number of this large tree and Y the small tree. And so your multiplication, the number of tree times the profit money, 55. So this expression alone represent the money that you get when you sell X a large tree. And this money represent the profit when you sell Y small tree. And this is my objective function. Now my constraints. My constraint is normally a set of the inequality that describe the limitation for the problem in the specific problem. Well, the first inequality is X greater than or equal to 0 and Y greater than or equal to 0. That means inequality number 1 and inequality number 2 say okay, my problem, my region lie in the first quadrant because have no sense to talking about -3. No second, no third, no fourth quadrant. Only my region lie here in the first quadrant. Okay, what is my next? Well, my next say in one problem, I re-reach the problem again. The monthly demand is at most, remember, at most is translated in mathematical symbol like a less than or equal, no? Y at least is greater than or equal. Pero no, in our problem, the problem say at most. The monthly demand of the tree is 310. Okay. So is the number of large plus the number of small should be less than or equal 310. And this is my third inequality. Everyone follow me so far? And the money that you need to spend to create, to grow this tree is given by the cost, que es the first column in the table, que es the cost, ¿no? Entonces es $110 multiplication by X, que es the amount of tree, no, large tree, plus 70 Y This money, this is the money, total money that you need to spend is less than, because the money is available for this company is only 29,700. And this is inequality number 4. Okay, so what should I do? Well, this is the most complicated part. We'll be able to set out the equation of inequality from the word problem. This is the challenge. Always is a complicated part. I understand this. That is a reason in the test I never put word problem. I put the linear programming problem, but from now, so we have the constraints. You try to discover the solution region, the feasible, that's the technical name, feasible region, and you determine the corner in the polygon, and you evaluate in each corner, you evaluate the objective function, no? And determine in what combination is the maximum and what combination is no maximum. Okay, entonces no, okay. Entonces, the only thing we need is Desmos and calculator. That's it. So I go to Desmos again one more time. Everyone follow me? It's confusing. It's a little bit confusing. No, it's not straightforward, but it's not confusing. Okay, it's clear. Yasmin. Yasmin, let's go to Desmos. Okay, boom. Okay. Let me see. This is Desmos. Okay, I suppose this problem is a problem number, I don't remember very well. Number 5 maybe. Let me see number 5. Number 5. Alright. No, not number 5. Number 6. Okay, number 6. Okay, and number 6, you can see the collection of the inequality. Case. Okay, let me put everything together, poof, and one by one. Okay, look, let me make a zoom out. This is my first, this is my second. Okay, this is the first quadrant. This is my third inequality, que represent a line, below because it's less than. And the second get the money and the cost. Bang. Entonces I discover que my problem contains my solution, my feasible region is formed by a polygon. Okay, by the way, we have 1, 2, 3, and 4, a quadrilateral, and we have 4 vertex. Okay, 0,310, 200, 1,110, and 270, 0, and 0,0. 0,0 is always trivial solution. Basically, I need to discover what is the idea, what's the maximum. Entonces, look at that. I want to do analytically. Now I go immediately in a few seconds to the whiteboard and we evaluate the C function and this combination. No? However, I put here a slider. This slider describes the objective function. And you see, look at that. When you approach it to the feasible region, I suppose que touch first. Bang! That point. Wow. And after, I continue touch the second point. And finally touch, or don't touch. Well, see, touch. In my slider, I need to change a little bit, but touch. So what mean that? What mean que the maximum, I suppose que is this point. Wow, amazing. So what is the fantastic conclusion? Look at that. The fantastic conclusion is que y is 0. And what is y? I don't remember. Y is the large. Well, no, y is the small, no? The small 3. small 3. Okay. That means okay, it's much better to sell only X. Okay, X is large because small is no. Now, this is a combination. Okay, maybe it's possible. Okay. I have no idea. Let me try. I come back to the whiteboard. Yeah, I discover okay, we have 3 famous points. Whiteboard. Okay. We have 3 famous points. Okay, the point was 0, 310. Another point was 200. And the other point is 270, 0. Now remember, X is large. It's important the organization. And Y is the. So we have 3 combinations. No sell large and sell 310. And you find the profit for this condition. And the profit formula is, remember, C is equal multiplication by 0 plus 29 multiplication by 310. And the answer is 8,990. This is money. This is dollar profit. Okay. Another combination is sell this and this. Let's see. This is 55 multiplication by 200 plus 29 multiplication by 110. And the answer is a little bit more large. It's $40,000. Okay. And another possibility is sell only large, no small. Okay, 55 multiplication by 270 plus 29 times 0. When I put in the calculator, it's close, but no equal. It's 14,850. It's obvious that this is the maximum value. This is value that optimize the profit, and this occur at the point X equal large 3 and no small 3. It's to sell small. This is the idea. Surprise. This is the magic of the linear programming problem. I have more example, pero no. I need to introduce in the time we have another super important topic. Guy, any question about linear programming? This is no, in the test I promise, well, in the review package you see some problem, but no word problem. O sea, the constraint is given, the objective function is given, and the only thing you should do is go to Desmos, solve the system, determine the corner, evaluate the objective function in the corner, and determine what is the maximum or minimum, depending on the optimization that you want. Good? In Desmos, why do you add? Okay. Let me try to explain. This is just complementary, no strictly necessary. But okay, let's try to explain. Look. Some student asked me how you put in the Desmos the objective function, professor, and how you introduce a slider. Okay, look at that. Do you see the Desmos part, mister? Look, Sean. I typing the equation. This equation is the objective function. 55x plus 29y equals z, no? Equals z. I don't know why. Well, there are several problems. I put A6. Yeah, I put like it equals 0. Doesn't matter. When you introduce in Desmos one extra variable, AC, Desmos say, well, what the hell is A6? Entonces, they automatically, Desmo create a slider. Okay, and now when you move the slider, you see the motion for the objective function, and you discover que es small difference in between this option and this option, but it's not super a lot of money, but it's a money can make a differences. Okay, Sean, do you see or no? Super. Okay. So I go to the whiteboard again. Okay, and today we start. Okay, today we start a new topic. In my opinion, is the most important topic. I love you that topic. Is solving system of linear equation Okay, professor, again, the same in linear equation, pero using matrices. Using matrices. Matrices. Using matrices. Okay, using matrix now. Okay. So far, we studied how we solving. Now, what is the problem of the classical solution, method for solution? It's crazy. It's crazy. Suppose we have an engineer problem. Suppose you have 15 equations with 15 unknown, because I make the design of the building. And the building have 15 floors. Each floor contains one equation. And I need to solve it. This is impossible by hand. This is impossible by hand. Why is impossible by hand? Because suppose you select the equation 1 and equation 2, and you delete one variable. No, you never finish. This is completely crazy. And now matrix apport a systematic way for solving any system. It doesn't matter the amount of equation, because you're following one strict algorithm. I want to explain now. And also, this algorithm, it doesn't matter if you have 15 equations, 100 equations, you solve them by computer. I want to show you how you solve it by computer. Okay? Okay, now the first thing you need to understand is how you change the language for the equation to the matrices. What is the organization of the matrix? Okay, suppose I come back again to the system, x minus 2y plus 3z equal 4. This is equation 1. 2x plus y minus 4z equal 3. This is equation 2. Minus 3x plus 4y minus c equal minus 2. And this is equation 3. And this is my system of equations. What is the goal? The goal is translate to the matrix language. Translate to the matrix language. The matrix language, what is the matrix? Matrix is a rectangular array. Rectangular array of the number. So you copy exactly the same, but without variable. You copy like that. There are different ways to express that. I want to play both ways. The most important way. Suppose I call one matrix A, capital A. Normally, the matrix is expressed in the notation using capital letter. Capital A is the matrix format, and we need to, some book, we using square bracket, the majority of book. Another book using parentheses, but I prefer bracket. And you copy only the coefficients in the front. 1, negative 2, 3, 2, 1, negative 4, negative 3, 4, and negative 1. Yeah, I copy only the coefficients in front of the variable without variable. So inside the matrix only we have number. It's numerical array. Numerical. No variable anymore. It's important to understand that this matrix have dimension, and dimension is the number of rows by the number of column. In this case, we have 3 rows. Look at that. 1, 2, 3, and 3 columns. 1, 2, 3. That is a reason that this matrix is a square matrix. Okay, sometimes you copy like that here. This is complementary information. 3 by 3, 3 by 3. What means this 3? The amount of rows. What means this 3? The amount of columns. No always is the same number, no? When it's a square matrix, it's a square matrix. It's when they are perfect coincident with the dimension of the row and the dimension of this. Do you say, well, professor, what about this guy? This guy is also, we can represent like another matrix, B matrix. And B matrix is formed by 4, 3, and -2. And this matrix is 3 by 1, because this matrix have 3 rows, 1, 2, 3, and only 1 column. And when this situation happen, this matrix que contain at least 1 dimension 1 is called a vector. This is the terminology. In this case, column vector. Because 1 dimension. When the 1 dimension is 1, we have another problem, row vector like that. Suppose 4, 3, and -2. In this case, we have 1 row and 3 columns. 1, 2, 3. This is the organization of the matrix, no? So far, this is clear. We study, for example, the augmented matrix. The augmented matrix is super important. Augmented matrix, matrix, you write like that in singular, and plural is matrices. It's the combination A and B together, right, to represent the entire system. Entonces, the augmented matrix is, you copy like that, A separated by the line B. We write now 1 minus 2, 3, 2, 1, -4, -3, 4, -1, separated by the line, is this line, and you copy B, que B is 4, 3, and -2. And this is the augmented matrix that represents perfectly the original system of the equation. Do you understand this or no? Super easy. The organization is trivial. It's trivial. Easy. However, Jasmine, I promise, not today, of course, I suppose, I don't know, que I teach how we solve the system using this new idea. We solving by hand or we solving by software. What software we can use? Well, we can use Geogebra. I teach how, it's available for everyone free online. I highly recommend that you create account. Exactly, you create account in Desmos. You create account in Geogebra. Geogebra Classic. They are very different version. Geogebra Classic. Please, as soon as possible. No, of course. I working too hard in the next class with the Geogebra class. Okay. Now we have time. Suppose let's do exactly the same idea, but in the one weird example. Suppose that we have it's example 2, no? Example 2. Okay. Suppose that we have a system x plus y equal 20. Equation 1. C plus y equal 40. Equation 2. And x plus 2y plus 3z equals 60. Equation 3. And my goal is write the matrix associated with this, the augmented matrix associated with 60. Entonces, the typical format for the augmented matrix is you open big bracket, you separate by the line the right-hand side number, que es 20, 40, and 60. And here the coefficients of the variable, but organized in that way, in alphabetical order, x, y, and z. Now, suppose the example that we have 15 equations. Well, no, okay, so you call like x1, x2, x3, to the x15, or whatever you want to call it. y1, y2. I prefer x. I don't know. Oh no, maybe it's the engineer problem. It's the tension of the force 1, comma, the force 2, comma, the force 3, and civil engineer, que es the building, ¿no? Entonces, okay. The x, in the first equation we have x, the coefficient is 1, and y is also 1. Pero C is missing, y C is missing is 0. This is the important thing. This is the important thing. And the second equation is completely crazy, disorganized, no x, 1y, and 1z. And the last one is totally completed, 1, 2, 3. End the story. This is the organization for the matrix. This is the right-hand side numbers. And you complete it when the one variable is missing is 0. Normally in the real-life problem of the engineer, in this equation, a lot of part is missing, and you complete it with the 0. Okay, now by the way, what is the dimension of this matrix? Well, remember dimension is row by columns. And we have 3 rows. 1, 2, 3. This is row 1. This is row 2. And this is row 3. No? By 4 columns. This is the column 1. Column 1 is the column of the x. Column 2 is the column of the y. And column 3 is the column of the z. And column 4 is the column always of the right-hand side number. Super. Okay, good, very good. Everyone follow me? Okay. Now, let me present to you what is the algorithm to solving this system. Algorithm. Well, actually, we have 2 algorithms. So, using one thing que I want to explain in a few minutes, que es the row operations. Row operations. We can transform it, this system, this matrix, in another matrix. Okay, in another matrix. What is the idea? Okay, the idea is, suppose we have a huge matrix. If I do something in order to put the first guy, the first entry, like a 1. Well, actually, look at that. In this case, I have this. Okay, nice. But if I don't have, we can interchange column. You can interchange. So one row operation is you move, for example, the row number 3 interchange with the row number 1 or number whatever. This is perfect legal because the order of the equation, I put 1, 2, 3, 4, 5. I don't care. This is totally arbitrary. I define by myself. So we can interchange. But it's important to start the algorithm. I need this one. And this one is called pivot 1. Pivot number 1. And this pivot number 1 allow me, using row operations, but another kind of row operations that I want to explain in a few minutes, create 0 below. Well, actually, this is 0 here. This is 0 here. I don't need to do. But in the third one, 0 here. Using row operation. Que this is similar. You don't need to understand 100% this idea now. This is similar to the elimination. So when you are doing elimination, you cancel out one variable, ¿no? Ajá, entonces, you continue, to finish the first column. This is the column 1. Okay, this is the algorithm too long, and we are doing not by hand, we are doing using a computer software. Now after that, I move on to the pivot 2. What is the pivot 2? Well, the pivot 2 is the guy, o sea, this guy, the pivot 1 is located in the row 1 and column 1, no? And the pivot 2 is located in the row 2, column 2. Okay, 2. And somehow I create 0 below. Exactly the same, doing row operation. Below this. And we continue. I go to the pivot 3, the pivot 3 is this, and the position 3, no? And create 0 here. When I finish, everything bam, 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 regardless the amount of equation that we have, we finish in 1, 1 here. And of course, in the right-hand side, the number change. This number, after the transformation, change. Okay? Suppose, technically, okay, this algorithm in this matrix, no? Or in another matrix. I have here in my paper one example. Okay, suppose, pero no, I don't want to see the process, only the last moment. In the last moment, suppose we have, look, this situation. 1, -2, 3, 0, 1, -2, the line que separa right hand side, 4, -1, and 0, 0, 1, and 2. Okay, suppose I have the original matrix. The original matrix, guys, was 1, -2, 3, 4, 2. Okay, you don't need to understand now where I come from this. Only the algorithm idea. Okay, 3, -3, 4, -1, and -2. This is the original matrix associated with the one system, no? Doing something, row operations, I create 1 here. Well, actually, this one is already created, and this one is also created, and this no. But below, this is the order. You working column by column. Column 1 first. When you finish column 1, you move into the column 2. Okay, I create pivot here 1, no, actually 1. Here I try to make 0 below, and 1 pivot 3, and so we have nothing below. Okay, and so we almost finished, because this is the column for the X, this is the column for the Y, this is the column for the Z. And so you see the last equation. Look, the last equation is 0x plus 0y plus 1z equal to. Therefore, es obvio que sí esto. Y ahí solve that. And you apply back substitution. Back substitution. Back substitution means que in the second equation, que es no x, I don't want to copy 0x again, y minus 2z equal -1. But I know que C es 2. Substitution here, C is equal minus 2 minus, plus 2, equal negative 1. Y is equal, bueno, this is a negative 1 plus 4 is 3. Back substitution, And now when you have in my hand Z and Y substitution in the last equation, okay, by the way, the last equation stays the same, doesn't change. I do not transform it. The last equation is X minus 2Y plus 3Z equal 4, no? But I have in my hand que C es 2, entonces X minus 2 times 3 plus 3 times C que es 2 is equal 4. And this is X equal 4 because this is negative 6 about the 6, X equal 4. Okay, this is one algorithm. Okay, by the way, the name of this algorithm is Gauss elimination, because it's similar to the elimination method that we are studying, but in multi-dimension. And Gauss is the last name of the most famous mathematician in the history, Gauss. Entonces, another guy helped to Gauss to improve a little bit this algorithm, que es Jordan. So we have another algorithm que is called Gauss-Jordan. Gauss-Jordan elimination method. Both are algorithm or method, whatever you want to call it. And what is the idea for the Gauss-Jordan? What is the apport of the Jordan? Well, the apport of the Jordan was, we start again for the first pivot, and you try to manipulate using row operation to make 0 below the pivot one. And you go to the second pivot, and you are doing exactly the same thing. So far it's identical. But Jordan apport, why no? Let's do it 0 above the pivot. So you continue this procedure. Look, this is the third pivot, and we are doing the 0 below and the 0 above the pivot. When you finish, we have a matrix like that. Boom, 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 boom. Okay, this is the right hand side, and this is just the number. Okay. Suppose that you have here the last pivot. Therefore, let's see this idea in one example. When you are doing this job, we have 1, 1, 1, get the 3 pivot. Below and above, we have 0. Sorry, we have only 1 0. 1 0 here, 1 0 here, 1 0 here, 1 0 here. And the number in the right hand side after the transformation is 4, 3, 2. Therefore, so you translate from the matrix language to the equation, is so obvious that this column is the X, this column is the Y, this column is the Z. The first equation is X equal 4. The second equation is Y equal 3. And the third equation is C equal 2. And we get exactly the same answer. Look at that. Maybe look like too long in this way. However, no. Because we are using calculator always. So let me try, in the time that we have, get only 15 minutes, to explain what is the idea behind the famous mysterious row operation. Guys, do you see, you understand? I suppose that you cannot understand the big picture so far. We have a lot of information behind this. This is the elementary, the basic idea. Introduction, kindergarten for the matrix now. Okay, let me try to present the row operation. que es the operation que the software are doing behind this row operations, elementary row operation. Suppose the first one, number one, que the name is interchange two rows, no two column, is illegal because you can interchange two row. Sorry, because the row represent equation, no? And it doesn't matter, two rows. Interchange two rows. So the symbolic way to indicate this idea is row 1 and row 2, you interchange like that. Okay, suppose example, elementary, no complicated. 2, -5, 3, 2, 5, 17. And you perform here row operation. What kind? Row 1, interchange row 2. Okay, so we get a new matrix after the transformation, que is 3, 2, 17, 2, -5, and 5. Okay, wow, easy. Interchange the row. This is convenient sometimes. Interchange, because the order gets given is not good. I need to manipulate. Interchange to row. This is possible legal. Interchange to row. The second one is a little bit more complicated. It's multiply a row by non-zero constant, by a constant. You know that this is possible. This is because when you multiply any equation, the system of equation, linear system of equation, and you multiply one equation by a number, you know that the next equation is depending, it's the same line or the same plane, depending if it's 2 dimension, 3 dimension, or multiple dimension. When it's multiple dimension, there are no possibility to represent geometrically, but we can work in algebraically. And normally this is called hyperplane. Hyperplane is a hypothetical plane in 4 dimension, 5 dimension, 6 dimension. Okay, but don't worry for this. Suppose you have the original matrix again. I perform this operation, que is 3 times row 1, storage, and row 1. Normally, let me see, we're using the idea for the normally. Okay. Normally we use a little case letter to represent the all row 1. This is row 1. This is row 2. And you transform it in new row 1. And when you multiply by 3 the entire row 1, 3 times 2 is 6. 3 times -5 -15. And 3 times 5 +15. Separate by this line is the hypothetical line que separate the coefficiency from the variable and the right hand side number. And the row number 2 stay the same because nobody touched. Only the information, the row que I manipulate was the row 1 multiplication by 3. You say, Professor, where I come from this 3? Depending on the situation. Okay, depending the algorithm select what number is necessary multiplication. Okay, now 3 is add. This is the most complicated. Add a multiple is multiplication, a multiple of one row to another row. Let me translate in English this idea. Suppose that we have exactly the same. 2 -5, 5. 3, 2, 17. I need, or the algorithm need, to make this transformation. Look, look. Multiplication by 2, the row 1, plus the row 2, and storage this in the new row 2. So basically, the row 1 and row 2 participate in the game, but the only information that change is the row 2. So row 1 stay the same, participate in the game, however, it doesn't change because the final answer you storage in the row 2. So you multiply 2 times each element in the row 1 plus the corresponding element in the row 2 in the same column, no? And this information you put inside the row 2. So 2 times 2 is 4, and 4 plus 3 is 10. No, 4 plus 3 is 7. It's 7. Okay, welcome from this 7. 2, let me copy here. This 2 times this 2 plus this 3. So in the same column. 2 times 2 is 4. 4 plus 3 is 7. Likewise, 2 times 5 is negative 10. Oh, times negative 5, sorry. Plus 2 es negative 8. Ok, entonces negative 8. Likewise, 2 times 5 is 10. And 10 plus 17 is 27. Yeah, I did the wrong operation. I'm using the algorithm Gauss-Jordan or Gauss algorithm, using only this kind of transformation, 1, 2, 3, row operation, and can manipulate everything. Guys, too much for one day. Okay, too much for one day. So now you should do several things to prepare for the next lecture. Number 1, go to the Geogebra Classic. You want to show you? You open your browser. I recommend Google Chrome. You open Google Chrome. Let me show you. Okay. Google Chrome. I recommend Google Chrome. I create the shortcut here, Geogebra. Okay. However, the first time you go here, Geogebra, I select Classic. Look, Classic. Geogebra Clásico, because my browser is in Spanish. You open that. Bam. This is Geogebra. I want to show you. I want to start new class. So, Thursday. How you set up the environment to working with the matrices, and how manipulate several examples super fast using matrices. Okay. Any question? What part is confusing? What part is not clear? I suppose everything is not clear today, no? Oh yes. I told you, this is the hard part. No question. It's just missing, no question. Okay. I told you, this chapter is super hard, and the last chapter is also hard. In my opinion, this is the hardest part. Okay, guys. See you. It is confusing. No, don't worry. Create account in the Geogebra. You need to create account using username and password. Exactly the same you did in Desmos. You are doing now in Geogebra. Okay? Take care.